What is going on? Professor Kimberling back with you one more time. So today we're going to go over acidic rain. But first, we got to go over the basics. The pH scale goes from 0 to 14. 0 being acidic and 14 being very alkaline or basic, in other words. An example of a 0 would be battery acid. You don't want to get that in your system. Or a 2 would be like lemon juice. On the opposite side, 14 would be drain cleaner. You don't want that in your system, I hope. And 12.6 is bleach. You definitely don't want to drink bleach. It doesn't end very well. And to put this into reference, normal rain is 5.6 on the pH scale. Relatively acidic, but not crazy. When compared to acid rain, it's a whopping 4.3 on the scale. This is a massive jump because the scale, the pH scale, is logarithmic. And if you know anything about math or, math, I don't, but people do. And they say that's a big difference. A 5.6 and a 4.3. Big issue. This acid rain forms from coal-burning power plants that produce sulfur dioxide or, nitrogen oxide or, dioxide, or carbon dioxide, all those NOx and SOx, all that reacts with water to make sulfuric acid, and that gets into rain, and that's not where it's supposed to be, arguably. This being rain can lead to reduced photosynthesis, calcium deficiencies, and this is a problem because the roots from trees can't take as much calcium as they need because the aluminum ions are present, and this leads to aluminum toxicity in the soil. I don't want that in my soil, do you? That's not fun. Acidic rain doesn't only affect trees, it also affects animals who are less tolerant to pH levels. It forces them to leave or even die in some cases due to the change of environment, and they're just not capable of living in that type of environment. My little lesson, my little review on acidic rain. Thank you for listening. Have a great night.